some of the operating systems, like the ROS. So this part is pretty straightforward, right? ROS is a framework, but although it's called a robotic operating system, but it's just a framework. It's not an operating system. It's like provide a pub-sub library framework for all the robotic components working together. So it's based on the pub-sub, not like a REST API request and response. So that's why pub-sub is kind of you can do a real-time response. And each node internally, you can have different library, all the things, dependencies, right? And when different node connect them together, simple point pub-sub. As long as you follow this message standard, two nodes can working together. So the original motivation for robotic operating system is like in the research area. There are so many different components or so many different algorithms by different researchers, right? And if you want to piece them all things into a one code base, there are so many different library dependencies, make things a mess. But instead, you can using each node as a black box and work with others by simply just using this real-time message exchange. And individual node can be in another machine, can be in the internet, right? Or can be in another processor. As long as you define this ROS message exchange, then can make things very simple. So because this framework, right, is very scalable, just like the internet, the REST API is very scalable. So that's why lots of researchers, right, they have new algorithm, right? They just publish in a ROS package, right? And you can download this ROS package online, right? And if you want to use this package in your robotic operating system, just set up another ROS node, right, to make it easy to utilize all the existing libraries, toys like that. So that's why ROS is a very good ecosystem with so many existing implementations, so many existing libraries. And you will find many autonomous systems that the original version is all based on the ROS, like Baidu Apollo. The early version of the Baidu Apollo also based on the ROS. If you without ROS, you need to write all the different algorithms, build the communication framework. But with ROS, so communication framework and even algorithm, some visualization software simulation, they are all existing library that can using ROS actually can make your life easier. This is a key benefit to utilize the robotic operating system. BMW. So in the real vehicle, like in the 2015, right, they already demonstrated their work, right? So they're using the automated driving, also using the ROS at BMW. We can skip this video. Okay, so so to play with the ROS, right? You can create the Catkin workspace. You can create a folder. Then go to this folder. You can using Catkin make. So you can it's a common to create this kind of the working folder, working space. They will also have the CMake list. If you're familiar with C++, you can specify different library things in the CMake list. Then you can then the current folder also have some build developer folders. Then you can on this folder to the source. Then you can get some of the those package passes. So here is some of the basic links, how to create some ROS packages. For example, we can simply create a ROS package. We can call it beginning tutorial, standard message, and with some of the packages like ROS.py, ROS.cpp. Then you will create files under this folder. You can set up packages in the package.xml. You can see this folder, CMake list. Then you can do the Catkin make to create your project. Then add the workspace to your ROS environment using this setup. You also can using ROS package list to see what kind of package dependencies you have. You can see this is some of the package dependencies. So if you want to run the ROS node, the first thing is that you need to run the ROS core. You can see the ROS communication versions. Also can see the ROS node info, can see the information of the different ROS node. The simple thing is you can run a total simulation with a single node. Yes, so you can using the loss run total sim, and then you also can run another node, just run RQT graph. You can see this kind of the graph about the node's messages to different nodes. Yeah, because when you publish sending the data to the different node using the loss PubSub. Loss PubSub is based on the loss topic. So you can subscribe to a topic using loss subscribe. You also can publish a message to another loss topic. You can use the loss topic list to see all kinds of the loss topic list. Yes, for example, this is a very simple loss PubSub example. So publisher sending data, maybe robotic ID to a subscriber, right? So you can create packages, like a hello robot, right, with dependencies for the standard message, loss pi, and loss CPP. Then you also create a loss message, specify this message type. This is the header is the name and the ID. So this is the message file. Okay, then add some dependencies. Dependencies of the message in the package.xml. Then added your CMake list, add some of your packages. Then find the add message file. You can do some modification. Generate messages, dependencies, standard messages. So you define here. Finally, find the Kazakin packages for dependencies message runtime. Then you can write the code, add the publisher CPP into the source code, subscribers CPP into this code. You can have the publisher and the subscriber individually in two different CPP code. Then add this publisher and subscriber into the CMake list. Then to run the Kazakin make, you can run the loss core source develop and do some testing. So you can run the publisher, loss run, hello robot publisher, then create a new terminal. This is a publisher. Then you can create a new terminal, run the subscriber. You can see there's two messages actually, two publisher and subscriber actually talking. This is you created the two robotic node. Previously, we can also using the, for example, we can using loss to play with the point cloud. So there's a very famous point cloud library, it's already in the loss. So you can go to this link to do a VoxGrid filter. VoxGrid filtering process is the first step in the LiDAR point cloud processing. So you can create a PCL test packages, CD source, also configure packages, CMake list file. After you write the code, you can do the CMake make setup, then loss launch point cloud PCL test. In the PCL test, you can you also can open Revers for the visualization. Then you can use loss backplay. This is your recorded data. Recorded data in a LiDAR test, like in the back. You can play the recorded data, go to your node. You also can run Revers to do the visualization. Then in the Revers, you can configure. Revers is a very famous visualization software. You can say, oh, I need validar LiDAR points in the point cloud true format. So you can play with the now you can do a different setup to visualize your point cloud, set up the point cloud size. So this is and utilize the built-in visualization packages in the loss to visualize the point cloud. The reason why loss is very popular because there are so many different visualization software. All things are already there, like point cloud library, and even point cloud visualization for the LiDAR is also there. Previously, we mentioned we can using the NDT algorithm for localization. matching with 2-point cloud. Then inside the PCL library, the NDT example are also there. You can run CMake this normal NDT transform. CMake. Then you can run this example. You can see iterative results. This is light scan. Green point is the HD map. The red point is another light scan of the room. They can step by step align them together. So this is NDT alignment process. Then you get the transform vector. This transform vector you can use to localize your work relative to the current map. So if you want to play with NDT, right? So that's also in the point cloud library of the loss. So there are for example, we can using 2PCD file, like 2-point cloud file, right? We can also apply the Vox filter out some original point cloud. We can using the PCL normal distribution transform, and step 4 we can do the visualization. Another thing is there are some autonomous driving system like AutoWheel, like AutoWheel project, even Baidu Apollo's project, like starting from Baidu Apollo 3.5, they added the NDT localization in their localization module. You can see this source code, LiDAR locator NDT, and it's PCL format. And actually, you can see they actually also using the PCL library in the loss. So they are PCL aligned, PCL point cloud and align. This is they're actually using the loss PCI library in the autonomous driving system. And that's why you can see why autonomous driving system like AutoWheel, Baidu Apollo early version are all based on the loss. Because some like PCI library, they can just use that. This is an NDT example. So in the Baidu Apollo, you can see their point cloud 2 data format. This is CN2 in the ROS2, right? And also can see their the parameters for the GPS location information. Then output is the localization results by the messages. What the Baidu did changes is ROS has their message format, but Baidu Apollo they changed the message format to the Google's protocol buffer format. This is Baidu's modification for the original ROS. They are also under the localization module NDT map. You also generate the NDT localization map. You also can see the code over there. You also can you need to list all the PCD file and create the NDT localization map. This kind of code is also available in the Apollo's localization module. Utilize the PCL point cloud library. There are also other interesting ROS projects. For example, CMU robotics. You can go to the CMU explorations to see some examples from CMU. Previously, we talked about like YOLO V3, right, or TensorFlow for 2D object detection process. Right? There are some projects integrated with the ROS with YOLO V3, also maybe ROS with TensorFlow. You also can see this ROS examples. Right? And AutoWheel and Baidu Apollo, the early version, also based on the ROS 1. Some students may have also heard about the ROS 2. ROS 2 is still in the development stages. It's been a long time, but it's still not very mature right now. But recently, I see there are some more adoptions for the ROS 2. You can check the latest ROS 2 implementation status. Now, one of the major benefits is the ROS 2 can support lots of the framework, like Mac, Windows, Linux. The original ROS 1 is only x86 Linux. So that's why ROS 2 has better support for ARM. If you have ARM's processor, ROS 2 may be better than the ROS 1. You can check the ROS 2 documentation. There are also some of the new projects. For example, NVIDIA has the ROS 2 for Jetson. You can using the ROS2.json and run the PyTorch, and the CUDA supported the OpenCV and also support the Torch Vision. You can have the PyTorch models integrated with the ROS2 and the JSON. So you can using the NVIDIA JSON run the ROS2 for your PyTorch models. Also, NVIDIA has a ROS-Torch TRT, TensorRT, PyTorch do the TensorRT acceleration. You can check the NVIDIA's ROS2 PyTorch TensorRT acceleration for the object detection models. Another recent work like EuroX. EuroX also has supported the ROS1 and the ROS2. If you are interested to play with like EuroX type, you can integrate with the EuroX ROS. So, okay, so so we are running out of time. Yeah, any questions for military exam or any question for the ROS, which is due to the time limitation, which is a brief talk about some of the ROS project. And if you are interested, you can check some of these links. It can help your project, especially some of the new links like from NVIDIA or like the EuroX ROS.